So here in this video, we're going to look at this question. So the question that I have here is 1.5 moles of an ideal gas at a temperature of minus 15 degrees Celsius and a pressure of 2 atm. What volume in dmq will the gas occupy at that temperature, given that R, which is the universal gas constant, is equal to 0.082 atm dmq per Kelvin per mole? So the first thing I would want to do here is to fish out the parameters, is to fish out the values that are given in this question. So the question is 1.5 moles of an ideal gas. 1.5 moles of an ideal gas. So that tells us that the number of mole of this ideal gas is what? 1.5 mole, right? 1.5 moles. So 1.5 moles of an ideal gas at a temperature of minus 15 degrees Celsius. So the temperature is what? Minus 15 degrees Celsius. And remember, in gas laws, we don't work with Celsius, we work with Kelvin. So if we are to convert this to Kelvin, this will be equal to 273 plus my temperature in Celsius. And the temperature is what? Minus 15 degrees Celsius, right? So plus times minus will give me minus. So that will be 273 minus 15. And that will give me 258 Kelvin. So minus 15 degrees Celsius is equal to 258 what? Kelvin, right? So back to the question. 1.5 moles of an ideal gas are at a temperature of minus 15 degrees Celsius and a pressure of 2 atm. So the pressure P is equal to what? 2 atm, right? 2 atmospheric pressure. What volume in dmq will the gas occupy at that temperature? What volume in dmq? So we are looking for what? The volume. Volume is what we are looking for in dmq. What volume in dmq will the gas occupy at that temperature, given that R, which is the universal gas constant, is equal to 0.082 atm dmq per Kelvin per mole. So our universal gas constant R is equal to what? 0.082. It was given in the question, right? So the next thing I would do after writing out the parameters is to write my equation for an ideal gas. So the equation for an ideal gas is PV is equal to nRT. This is the equation for an ideal gas. So the P is for the pressure, the V is for volume, N is for the number of moles, R is for the universal gas constant, and T is for temperature in Kelvin. So what I'm looking for in this question is V, the volume in dmq. So I would make this volume the subject of the formula. So to make this volume the subject of the formula, I would divide both sides of the equation by the coefficient of this V, which is P. The coefficient of V is that number or that alphabet that is attached to what? V. So what is attached to V? It is P, right? So this will be divided by P, divided by what? P. So this P will cancel out this P so that the V can stand alone. So my V will be equal to nRT over what? Over P. So this will be equal to my N, which is the number of moles, is what? 1.5 moles, right? So that is 1.5 times my R, which is the universal gas constant, is what? 0.082. So that will be 0.082 times T. My T is the temperature in Kelvin, and it is what? 258 Kelvin. So times 258 divided by P. What is my P? My P is what? 2 atm divided by 2. So my V will be equal to 1.5 times 0.082 times 258. That will give me 31.734, right? Divided by these two, divided by 2. So 31.734 divided by 2, if I press that in my calculator, 31 0.734 divided by 2, that will be equal to 15.867. So that will be equal to 15.867 dm cube, because we are looking for what volume, which is measured in dm cube. So this is my answer to this question. So my volume is equal to what? 15.867 dm cube, right? So this is actually a very, very simple and straightforward question. The main thing here is for you to be able to fish out your parameters, which are well spelled out in the question. And then the next thing is for you to be able to apply a formula, your equation for an ideal gas, and the equation is PV is equal to nRT. So this equation is something that you must remember always, right? All right.